Hey guys, let's look at lesson 53, and we're talking about exponents and what's called the power rule. And let's look first, let's kind of slide into it gently here. And you tell me the answers to these. You should know the answers to all the questions, the 4 questions on this page. So first off, we'll go x squared times x to the 5th is x to the 7th. You just add those. X to the negative n, by definition, is 1 over x to the positive n. All right, x to the 0 by definition is 1. All right, and x to the 12th divided by x to the 7th, we know we subtract, so that's going to be x to the 5th. Okay, all those, remembering those is important as we do what we're going to do next, because what we're doing next, when you look at it in your book and on practice problems and things like that, it looks tremendously complicated, and I'll show you why in a second. But all you need to do is remember, you know how to multiply, you know how to add, you know how to subtract, and you remember, look at those 4, you remember exactly what to do with all 4 of those, you'll be good. All you need to do is just do it several times, okay? So let's do something, and again, a lot of algebra is just recognizing that certain things work with normal numbers over and over and over every time. So they just go, okay, well, we'll just call any number x, and then it works with anything. So we can just say that everything works with this number, or this technique. So look at that question right there. We have 2 to the 2nd power, which we need to figure out, which is going to be 4. And we bring that to the 3rd power. In other words, this is 4 times 4 times 4, and the answer to this is 64. Okay. All right, let's go another one. 3 to the 1st power brought to the 3rd power. Well, 3 to the 1st power is just 3, right? 3 to the 3rd power is 3 times 3 times 3, or 27. Okay. Let's go back first before we do that. By the way, you should recognize the fact that 64, if you want to write it as a power of 2, you go 2, 4, 8, 16, 32, and 6. So 64 is actually 2 to the 6th power. Okay. 27 is 3 to the, since we're messing with 3s, 27 is 3 to the what power? 3, right? Okay. Now look at the pattern. Look at those 2 problems, and you tell me what pattern we've developed that works both times. Okay. We've got 2 to the 2nd brought to the 3rd power is 2 to the 6th, and then 3 to the 1st brought to the 3rd power, that's 3 to the 3rd. And I'm sure you recognize all you've done is just multiply the 2 and the 3, and then multiply the 1 and the 3, and we get this number here. Now that is different. Don't get confused. If we go, you know, x to the 2 times x to the 3, we still go, okay, we add those, that's x to the 5th. But if we go x to the 2nd, you bring that to the 3rd power, that is x to the 6th. Because what's actually happening is you're going x to the 2nd times x to the 2nd times x to the 2nd. In other words, you have this, x to the 2nd times x to the 2nd, no, times x to the 2nd. And you can count them, there's 6 of them. So at some point somebody just went, hey, I discovered an algebraic rule, we'll just apply it to everything. And here's what you commonly see, this one, if you want to write this down and remember it. X to the m brought to the n power is just going to be x to the m times n. We don't have to write anything between the m and the n, and the n to let us know that it's multiplied. So that's it, okay? All right. So let's do this one. A to the 5th power squared will be a to the 5 times 2, or a to the 10th. All right. X to the negative 4 brought to the negative 2 power is going to be x, and then negative 4 times negative 2 is positive 8. We're just multiplying those. M to the negative 2nd power brought to the 8th power is going to be m to the negative 2 times 8, or negative 16. And that's the difference. Okay. Here's the last one on this page. P to the negative 5 brought to the negative 3rd will be p to the negative 5 times negative 3, which is positive 15. And there we go. Okay. Ooh, I forgot one more. It was kind of a weird one. M to the k power? What the heck does that mean? Anyway, squared? Okay. Well, again, we don't care. We don't have to pretend to know all what's going on here and all what's happening and all this. All we need to do is go, well, there is there's a policy we follow. There's a rule we follow. If it works for all of them, just do it for every single one that ever, it's there. So m to the k brought to the second is simply k times 2 or m to the 2k. And we don't know what that means. We don't care. We're just doing an exercise practicing how to do this. All right. Another one. This is slightly different. Copy this down. Take a second and look at the slight difference in this one and the ones we've done before. Notice the difference? Well, the difference is obviously the 9, right? Okay. Well, which tells us what you're going to have to do in each one of these is go ahead and apply the squared outside the parentheses to everything inside there. So it's not just the 8 to the 10th that gets squared, it's the 9 as well. So we know that 9 squared is 81, okay? Then the a, we're going to go a to the 10th squared, which basically, just here's a reminder, a to the 10th squared means a to the 10th times a to the 10th, which we know is a to the 20th. There we go. All right. Here's another one. Now this is getting a little complicated. Now this is what I meant a few minutes ago when I said it's going to start to look so complicated in the fractions, the x's, the negative exponents and all that stuff. Don't let that intimidate you. All these are, I mean, you know how to mess with fractions. You know how to, deal with multiplying and adding, even negative and positive numbers. That's all you're doing on these. Okay. Well, let's look at this one. 3/5 brought to the negative 2 power. Well, we already know that this is the same thing as 1 over, by definition, 1 over 3/5 to the positive 2 power, right? Okay. Well, we can just keep going. That's 1 over. Now 3/5 squared, we know how to do that. We just do the tops and the bottoms. So we have 9 on top, 3 squared, and then 25 on the bottom. Now 1 divided by 9/25. We know how to divide fractions, right? We just take the first one. We call it 1 over 1 this time if you want. We'll take the second one and we flip it and we multiply it. And of course, that's just going to give us that as an answer. And there we go. Well, if it works for actual numbers and fractions, it'll work with x's and y's too as well. So let's do one. So take a second here, copy this thing down. And all right, I'm assuming you've paused it. So all we need to do is just look at each part of that fraction and square each part. There you go. So let's do the top first. So 4 squared is 16. X, and we can call each one of these, 1 if you want to. And don't forget, a power brought to a power, you take the numbers and you multiply them, you don't add them. So this is going to be x to the first squared, which will give you x to the 1 times 2. Same thing with a y to the 1. Oop, there we go. Then the bottom, we get m to the second, a negative second squared, which means you just take the m and you multiply. Negative 2 times positive 2 is negative 4. And in your book, they might ask you, write the answer with all exponents positive or whatever. Well, fine. Then just goes way up here and turns into m to the 4th power, if you want to do it that way. All right, here's another one. Again, take a second, pause it, and copy. All right, and again, this looks complicated to deal with, but you got to just make sure you convince yourself all you're doing is you're multiplying and you're adding and you're subtracting, and you're doing a couple of little, techniques that you've learned how to do before. All right, and you can take as many steps as you want to take with this, but let's just do it one at a time. Okay, let's just do, since we're going to do fractions, let's just do the top first, and we can mess with that in just a few minutes. Okay, we'll take the 3 first and go, okay, well, that's going to be 3 to the negative 2. We'll just leave it that way for a second. Now let's do the x. We got x to the negative 2 brought to the negative 2. Negative 2 times negative 2 is 4. We got a y. 5 brought to the negative 2 is negative 10. Now we're done with this part. Okay. Now let's do the bottom. We got z to the 4th brought to the negative 2. Well, 4 times negative 2 is negative 8. Okay. Now the weird thing is you probably don't want to leave this, the rest of this you can get away with, and sometimes again they'll tell you, oh, make this all exponents positive or whatever. Let's just treat it that way. Let's just pretend they gave the instructions to make all exponents positive. Well, one thing you're going to want to do anyway is to take this and go, ugh, this is kind of weird looking, 3 to the negative 2. Okay, well, we know the answer to that. We could go down here and do it separately and go, oh, 3 to the negative 2, that's 1 over 3 to the positive 2. In other words, the technique you would do this is you would go, okay, I'm taking this 3 to the negative 2 at the top of the fraction. It goes down here. I'm sticking it down there. You tell me what it becomes. 3 to the negative 2 up there becomes what down there? 3 to the positive 2, right? Well, what is 3 squared? 9, right? Okay, there you go. Your x to the 4th is good, and you know, if you want to make it to all positive, that's good. This y to the negative 10th is not. We will move that down here, and it turns into y to the positive 10. And then we'll move the z to the negative 8th from down to top and go z to the positive 8th. And there you go. And don't forget, you know, if you have this as an answer here with your negative exponents, and maybe you put your 3 to the negative 2 down here and turn it into a 9, that's perfectly fine. In fact, anytime you see an answer that yours looks different than what they have in the book, just take what they have and move it up or down, wherever, and then change the sign of the exponent. And then if it compares, you got it. Don't worry about it. Okay. Here's another one. I'll let you guys take a second here to copy this down. Okay, I'm assuming you copied it down. And again, let's just take each one of these. We're distributing basically the negative 5 power to everything in here. So without even getting complicated, let's just call it what it is. There's 2 to the negative 5 power. Okay. This part, a to the negative 2 brought to the negative 5. Negative 2 times negative 5 is 10. Done. B squared, that'll be 2 times negative 5. Done. Z to the negative 10 brought to the negative 5, that'll be 50. Okay. Excuse me. And again, it's okay to leave variables with their the exponents negative, no big deal. It is weird to leave like base numbers like this with a negative exponent. So let's go ahead and treat this as a big fraction with a 1 on the bottom, of course. And let's move this down here. So we have, in other words, we're going to say 2 to the 5th power down here. Well, what is 2 to the 5th power? 2, 4, 8, 16, 32. We'll put a 32 down here, and we'll get rid of that. And there we go. And that's our answer. And I hope you're seeing that this is, we're still just adding numbers, we're subtracting numbers, we're multiplying numbers, and so on. And a couple of little techniques like moving this with a negative exponent down and changing the exponent sign. That's all we're doing here. Okay, here's another one. Copy that down, give yourself a second. Okay, again, this, wow, this is so complicated looking. You know, look at all those, the fractions, the parentheses, the negative, the exponents, the variables, all that stuff. But just be very precise about it and do one little thing at a time correctly, and it'll all fall together. All right, and if you miss a couple, who cares? Fix them and figure out what you did. That's what Saxon math is all about. Okay, so let's do the top first. 3 to the negative 2. I'll call that a 1. 1 times negative 2, negative 2. And the y, negative 2 times negative 2, 4. Okay, done. P to the 5th brought to the negative 2, p to the negative 10th. Okay, now again, this is kind of strange. We don't usually see numbers, you know, actual numerals, constants in that format. So what we're going to do is go ahead and just pop that one down there. That turns into 3 to the positive 2. 3 squared, of course, is 9. And then there you go. You can call that your answer. And if your answer looks different from the books, again, flip their, their variables to the top or the bottom and make sure the exponents match up when you flip them. So, okay. All right. Copy this one down and try it. There's a little trick to it. See if you see it. All right. Well, if you notice, 2 to the 0 power is just 1. So you don't even need to, 1 to the 10th power, 1 times itself 10 times is still 1, okay? If you recognize that at the very beginning, great. If you didn't, guess what? It's no big deal. Because what will this 2 to the 0 power brought to the 10th power be at the end? When we do this? It won't be 10, right? We're not adding these. We're multiplying them, right? So 0 times 10 is still 0, okay? Let's do the x next. X to the negative 20, y to the 40, that's a 0, and then z to the 10th. Okay. Now again, look at this new fraction. Anything to the 0 power, you can go done. Okay, just leave it. This is good. This is good enough right there. That's it. Okay. But the second half of this, we're going to convert volume. So far we've done, a length converting to a length, that's one dimension, which we used one fraction for each conversion. Then we did square feet or square centimeters or square miles. So we did two fractions, or at least we did 2 times that unit. Now we're going to use 3, because volume, of course, is 3 dimensions. It's this way, it's that way, and it's actually up. Let me try to draw this here. I'm not too good at drawing these, but let me try. We'll draw 3 dimensions here. Well, that was pretty horrible. This line we don't need to. Okay, so anyway, here's 1 dimension. In other words, here's a dimension, and then here's the 3rd dimension. But let's go back first, okay? Give yourself a second and copy this problem, or at least solve this problem. So pause it and solve this overview problem. Okay, and don't forget our technique is whatever you're given, you write that down, 20 miles. All right? First thing you do is you write yourself a new fraction, and the unit you're going to have on the second fraction will be exactly this fraction here. That'll be miles. Don't even think about it, you just put it there. All right, well, we go 5,280 feet in 1 mile, so cross out your miles, and then you go 20 times 5,280, and then we have feet, and I won't even bother to do the arithmetic, but that's how you do your answer. Okay, let's do another one. There's 2 dimensions to this one. That was a 1-dimensional, right? Just a straight line. This will be square miles, which is 2 dimensions, right? 1, 2, which is why I have a little 2 on there, square miles. Okay, so go ahead, copy this, or at least write what you need to do to solve this problem, and then pause it, and we'll come back in a second. Okay, 50 square miles, you can just write 50 square miles, and there it is, okay? Now, remember the last one, you just had 1 fraction to undo your just flat out miles. This is going to be square miles, so you need 2 fractions, each one with miles, and then, miles, like that, okay? Which, in other words, this undoes those 2. So again, it's 5,280 feet is a mile. 5,280 feet is a mile. So, you have 50, good gracious, times 5,280 times itself, which is squared, and then a foot times a foot is a foot squared. So that's your answer, and so on. Okay, now let's move into uncharted territory here. So we're going to do 3 of these things. A cubic foot. Can you visualize a cubic foot? I mean, a square foot might look like this, right? 1 foot, okay, 1 foot, and so on. A cubic foot will look like the cube we just did a minute ago, where it's a cube up, a cube this way, and then a cube back, and so on. Okay. All right, we're going to use 3 multipliers to convert 100 cubic feet to cubic inches. Now, first off, for a second, just visualize. Can you visualize 1 cubic foot? Okay, now visualize 100 of those laid end to end. You could even visualize 10 cubic feet, by 10 cubic feet, that'd give you 100 cubes total, okay? How many cubic inches are in that many? A big number, obviously, okay? But we can do this, the same exact method we've done before on just regular old miles to feet, one dimension, 2 dimensions, we can do 3 dimensions. All we do is we just add 1 more fraction, right? So the method is exactly the same. 100 cubic feet is what we're given. You just simply write it. Now when we do cubic, we do a 3 because it's 3 dimensions. You want to write yourself as a fraction? Okay. Because of that, you're going to have 3 fractions now with foot or feet at the bottom to undo that 1 fraction because there's 3 dimensions, right? So without even thinking, just go feet, 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 and so on. Don't even need to think about it. All right, we're converting to inches. Well, we know a foot is 12 inches, a foot is 12 inches, a foot is 12 inches, okay? We can go ahead and go, I got feet to the 3rd power on the bottom, feet to the 3rd power on top. Now we have cubic inches. Well, inch times an inch times an inch, that's a cubic inch, like a little square, or I don't know, like a die or something like that you roll for a board game. All right, well, the nice thing about these is you don't even need to do the arithmetic. Just write 100 and then write 12 to the 3rd power. There's 1, 2, and 3 of them. And then cubic inches, which has a little 3 right there. So if you wanted to go ahead and do 12 times 12 times 12, that'd be 1,728 times 100. Let's just do it. Times 100, it means you just add 2 zeros. So that's how many of these. In other words, like, you know, here's a cubic foot, right? And here's a cubic inch, right? Just sitting in there like that. Well, in each one of those, there's 1,728 of those. Boom. And then in 100 of them, there's 172,800 cubic inches in there. And that's the method. All right, let's try one. This is a weird one. So we're going to have to mess around for a couple of times on this one. But look what we're converting here. Cubic centimeters to cubic feet. Can you visualize a cubic centimeter? And then that's like a sugar cube, right? You'd stick in your coffee. So 800 of those, how many cubic feet is that? Well, same method, but we're just going to have to do 2 different conversions this time. So again, you write what you're given. 800 cubic centimeters. Don't even think, just write it. 800 cubic centimeters with a 3, right? Boom, there you go. Okay. Again, we know we're going to have 3 examples of centimeters at the bottom to undo this. So you just do it. It's a centimeter times a centimeter, okay? Well, centimeters to feet doesn't exactly go, right? And that isn't one we memorized, you know, already before. But we can do centimeters to inches, right? So if you remember, an inch is 2.54 centimeters. So we'll have to write that 3 times. Right? Okay. So now this crosses, and then 1, 2, 3, those are gone. But now we have an inch times an inch times an inch. It's a cubic inch. We don't want cubic inches, we want cubic feet. So we have to do one more. So we have inches on the bottom, inches on the bottom, inches on the bottom. Okay. So we have, obviously this is 12 inches to a foot, 12 inches to a foot, and then 12 inches to 1 foot. And then of course you go inch, 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 crosses out inch, inch, inch. Now we have a foot times a foot times a foot. That's a cubic foot. That's what we want because they want cubic feet. Now the nice thing is, again, you don't need to do all this arithmetic. Just write your fraction. 800 times 1 all the way across, 800. All right? Then you have 2.54. That is going to be 1, 2, 3 of them, so just cube it. And then 12 inches 3 times, it'll be just 12 to the 3rd power. You want to put parentheses, you can. And then the unit is, we still have the cubic feet, so we want that. So just feet to the 3rd power, and that is it. And if you wanted to, again, you could do the arithmetic and cube 2.54 and 12 and then figure out what it was, but you don't have to. Okay, that is it. All right. We'll do 3 practice set problems, so pause and try A here. All right, I'm going to take care of the numerator first. 3 to the 0, well, you know, let's just say I forgot. That's still going to be 0 times negative 3 is 0. Okay, the y will be negative 2 times negative 3. The z will be negative 15. The bottom will be x to the negative 9th power. Now, of course, I recognize right away 3 to the 0 is just 1. No point in writing that. And, you know, you can leave it. This is good. Unless they tell you other instructions to do with those exponents. Okay, pause it and try B. No, this is a nightmare. There's 2 of them. Okay, they tricked us here. So I'm just going to do one at a time. We'll just do this one first. All right, let's just go again straight on. Well, you know, I'll go down this time. How about that? So I got x will be to the negative 4th. Y will be positive 4th. 3 will be, you know, 3 to the negative 2. M will be negative 8. And then K would just be, you know, 1 times negative 2. There we go. All right. Okay, I'm going to multiply this. I can just do it like that if we want to, since this is going to be spread out here. Y to the negative 2 times 2 is negative 4. And then M to the 1 times 2 is 2. X will be 6. And then K to the 2nd. Okay. All right. All right. If we need to go across now, which is what we do with fractions. Here's what we can do first. Let's do this. This is bugging me being down there. I'm going to flip this up here and turn it into 3 to the positive 2, which is the same thing as 9, right? So I'm going to get rid of that. I don't like seeing that. Okay. So I got a 9 times up, and it's just 1, so 9. All right, now let's go with, okay, x to the negative 4th. Oh, that's it. So just x to the negative 4th. Okay, y to the positive 4 times y to the negative 4. We'll add those together. That's y to the 0, which is just 1, right? So those are gone. And then m squared. Now the bottom. Excuse me. All right, so let's see. We got m to the negative 8. K to the negative 2 times k to the positive 2 is just k to the 0, which is 1. Then we have x to the 6th power. Okay. All right, well, if you look at this, we can reduce, right? We can combine these and reduce. Let's just go all positive exponents, okay, to make it, you know, I don't know, look nicer or something. All right, which means we're going to move this down here, which will turn into x to the 4th power, and we'll get these together, okay, gone. M to the negative 8th, I'll bring that up here, and that turns into m to the positive 8th, okay? So I have a 9 there. I have an m to the 2nd times the m to the 8th, which is m to the 10th. And I have x to the 6th times x to the 4th, which is x to the 10th. And there you go. Now look at that question again. I'm just going to do all the, let me get this, erase all this thing. That it looks complicated. And that is, I mean, I got fractions, we got x's, we got exponents, we got negative exponents, all that stuff. But bring it down to a level where you know you're going, okay, I'm following certain rules, I'm multiplying and I'm adding, and certain things here and there where you know, you take this and go down there and, you know, change the sign of the exponent and you got it. Okay, so pause it and try C. All right, here is C. Use 3-unit multipliers to convert 75 cubic inches to cubic centimeters, okay? And again, no thinking, just write what you're given. 75 cubic inches. There we go. Okay. Well, you don't have to think. You just know you're going to have 3 fractions with inches to undo that. The cubic centimeters, well, we know that, you know, 2.54 centimeters is an inch. 2.54 centimeters is an inch, and then 2.54 centimeters is an inch. There. So that crosses, there's the 3, 1, 2, 3. Don't even need to worry about the arithmetic. 75, and you can just write 2.54 centimeters, and then, oops, 2.54 to the 3rd. And then that'll be cubic centimeters there. Okay, and that is it. Y'all have a good rest of the day.